everyone. Thanks a lot. My name is Dan Phillips, and today I'm going to be talking about WebAssembly. Who's heard of WebAssembly? Cool, right on. All right, who's heard of WebAssembly on the server? All right, one. Yes, we got one.
Yay.
Okay. Yeah, nice. Okay, great. So, some feedback. Let's see. Yeah, so like I said, my name is Dan Phillips. A little bit about me. I'm an engineer at a company called Loophole Labs. We are a small little startup that does infrastructure tooling. I live in Chicago. I also run the Chicago Wasm meetup, the WebAssembly meetup there, and I used to help out with the Ruby meetup in Chicago. So if you're in Chicago, hit me up. I work on a project called the Scale Function Runtime, which uses WebAssembly as a plugin framework so that you can run multiple languages in the same runtime together safely in a sandbox way, which I'll talk about a little bit more briefly. And on the internet, I'm D_Philla, GitHub, just dphilla with no space because you can't use underscores, of course. And like I said, yeah, Wasm Chicago, check it out, wasmchicago.org. All of our stuff's online, so anyone is available to check it out. And it's also only a 2-hour time difference from here, so. Cool. So what is WebAssembly? WebAssembly is abbreviated Wasm, and technically it's not all caps, it's capital W-A-S-M. It's a safe, portable, low-level code format which is designed for efficient execution and compact representation, meaning this is coming right from the spec itself. So what does that really mean? It's a safe sandbox execution environment which is deny by default, and it makes no assumption about languages or host. The analogy with WebAssembly, a good way to think about it, is as a virtual CPU, a virtualized CPU. So it's a compilation target. Much like other compilation targets, x86, ARM64, you can think of it like metal, basically. You can think of it like another CPU. It's a virtualized instruction set architecture, ISA. It uses a bytecode binary format, so if you're familiar with Java and the JVM, it's very similar. Ruby's virtual machine bytecode, it uses a similar bytecode format. But it's an abstract stack machine, right? I'm not going to get into too many of the low-level details about this, but it is something that, that is important. We can talk more about it later. So what does that really mean? What does that actually mean? In the broadest sense, it's just another architecture, right? You can compile things that you would compile to binaries to a WebAssembly binary. Key differences are that it's virtualized. It needs a runtime to translate to machine code. And that translation step is interesting because the translation step does not necessarily mean that it's interpreted. You can use it as an interpreter, or you can also compile ahead of time, AOT compiled. And there's all sorts of optimizations that happen that turn the WebAssembly into machine code. And it's universal, right? Cool. This is a horrible little graphic that I have, but I'd like you to take a look. WebAssembly, this is how it works in the browser, right? On the left-hand side, you have the JavaScript, and on the right-hand side, you have the WebAssembly, right? These are the only two things that modern browsers can execute. JavaScript and WebAssembly, that's it. There's a boundary between these two, right? You'll see that you have exposed functions, which means that if you want to execute a JavaScript function from Wasm, you need to expose that to the WebAssembly module, and the same thing in reverse, right? And then you'll see at the bottom, there's a linear memory segment. This is how you pass data between the two, right? In JavaScript, in browsers, it's usually the array buffer format. In other languages, it's byte slice, etc., right? And this is just a raw piece of bytes, basically. So a client-side technology. Most of us know about WebAssembly in the browser, right? Using it. Maybe you've heard of some of the cool stuff that like Google Maps does with it, or Figma. They use WebAssembly to compile some C++ image libraries to Wasm, and it sped up some of their shader processes. So we know of it as a client-side technology. This is from the spec. Again, a safe sandbox execution environment makes no assumption about language or host. This is very important. What else do we find out about it? Cold start times, right? Who's used containers? People use containers in here? Docker containers? Yeah, right. It's shipped now in Rails 7, 8, 7, right? Yeah. Yeah, okay, so it's like out of the box. We just have it, right? So how about cold starting a Rails app in a container? Has anyone experienced any pain or struggle with that? A little bit, sometimes. It depends on the size of the app, right? For sure. So cold start times of WebAssembly modules of roughly the same size can be in the microsecond to maybe 1 to 2 or 3 milliseconds from not running at all. And it's a universal compilation target. So there's an interesting saying that we have in the WebAssembly community, which is Wasm is not necessarily web, neither is it assembly. So the spec doesn't say anything about the web, anything about browsers, and it doesn't say anything about assembly, although there is an assembly-like text format called WAT, W-A-T, which is actually, in my opinion, easier to read than like x86 assembly, if you've ever had the displeasure of doing that. So server-side WebAssembly, excuse me. This is what I work on a lot. It's kind of interesting, and I like to think of it as sort of cloud infrastructure's penicillin moments. If anyone knows the story about penicillin, how it was discovered like by accident, there was like some mold growing, and then they were like, hey, this cures diseases. WebAssembly is very similar. So if you squint and you look at WebAssembly and you say, it's like a sandbox. It contains code. It's very fast. Nothing knows what's going on from the outside and between modules. You can kind of start to think of it as the next step in this progression, which is VMs provided hypervisor level isolation. Containers provided even more isolation, kind of. But if you know how containers work, it's more like the appearance of isolation, right? And then WebAssembly, right? So doing the same sort of things in smaller and more performant ways. And I'm going to kind of talk about this more. Right. And this is why the title of the talk was smaller, safer, faster, and much more universal. Faster has an asterisk, though, however, right? And I'm going to get into why there's an asterisk, right? Cool. If anyone knows this quote got a lot of investors very, very excited a few years ago. Solomon Hykes, who's the creator of Docker, said that can you guys read that? That's too small, isn't it? Okay, sure. If Wasm and WASI, and I'll talk about WASI in a minute, had existed in 2008, we wouldn't have needed to create Docker. This is how important it is. WebAssembly on the server is the future of computing. A standard system interface was the missing link. Let's hope WASI is up to the task. I'll talk about WASI. WASI stands for the WebAssembly System Interface. And I'll mention that in a couple of my next slides here. So that's an interesting thing to think about. WASI, the WebAssembly System Interface. This started in 2019, so relatively recently. WebAssembly's only been around. The MVP came out in 2017, I believe, right? So I was talking to some people last night, I think, and we were talking about how people have been hearing about WebAssembly for so long, but like no one's using it. Why isn't anyone using it? Like there's all this buzz about it, and the reason is that it's very, very primitive, right? Remember, it's just a CPU. That's it. Right? There's no operating system. There's nothing else that comes with it. There are no syscalls. So WASI is the system interface that was kind of modeled after POSIX. We've heard of POSIX, right? POSIX, okay, the portable operating system interface. This is what things like Ruby were built with those assumptions in mind, Unix operating systems. So it started in 2019. It uses a different security model, though. Has anyone heard of Plan 9, the operating system? Yeah, we got one in the back. Maybe two. Okay. Plan 9 was an interesting operating system that came out after Unix by the same people from Bell Labs that created the Unix operating system. And Plan 9 was the attempt to address some of the problems with Unix. And it never really caught on, unfortunately. So Plan 9 did some really cool things. Anyway, WASI takes some of these ideas and brings them to this set of interfaces. Right now it's an evolving standard, so it's not even at 1.0, it's at 0.2 now. So Preview 2 was just released. This means that all of the runtimes have to introduce it, so it's going to be a longer process, but I'm going to kind of talk about what that means for actually using WebAssembly today. Is it required? No, it is not. So if you remember that first slide, you had the JavaScript, right, which is the host, and you had the WebAssembly, okay? WASI is just a set of interfaces between the two that are standardized, just like POSIX, right? So when you open a file on your computer in a Ruby program, if you're on Mac or Linux, you know that that's going to be an open syscall, a read syscall, and maybe a write syscall if you're going to do something with it. That is all standardized, right? But WASI is still evolving, and so it's just a set of choices that the virtual CPU makes. Cool. So briefly, I should talk about my company, right? This is why they sent me here, right? So this is the project that I work on. It's called Scale, scale.sh. It's a plugin framework. Remember I said that WebAssembly is a safe sandbox, tiny, quick, performance technology which you can compile, in theory, any language to. And there's more and more support for compiling to Wasm every day. So what that allows you to do is to have really quick, small, safe plugins from other languages. For example, you could do something like build a serverless function runtime and compile it to WebAssembly. In fact, we have a few Shopify people here. This is how Shopify uses it in their Shopify functions runtime. They use WebAssembly for basically extending their Rails app, right? Like Shopify, a big part of it is a monolithic Rails app, from what I understand. And this allows people to use user-defined functions inside their code and on their servers safely. You can do polyglot programming in the same runtime. So what does this mean? This means that, like, if you have to use an SDK or something, or you have to use something like middleware, right? What if that middleware for this particular service or company isn't available in Ruby? Right? But it's available in Python, and like if you had to, you could read Python and figure it out, right? No big deal. You could use this runtime, and you could compile that Python into WebAssembly, plug it into your Ruby app, run it, and you wouldn't have to do anything with the low-level type translation, right? That's just one use case. We found something cool. If anyone does Golang in here, this is written in Go, and we found out that, so Golang's regex library is kind of slow compared to some of its other libraries. So what we did is we took Rust's regex library, and then we used Scale, we plugged it in, and then we had a 4x improvement in speed over native. So 4 times faster using WebAssembly, which was 4 times faster than the Golang native code. So there's a lot of cool things you can do with this. Some people have talked about this being kind of like the end of middleware. Like, you don't need middleware. You don't need to write middleware in Java, Python, PHP, whatever. You can just have one and plug it in, right? It's kind of a cool thought. So yeah, check it out. Give it a star. My boss will never forgive me if I don't talk about it. So cool. Oh yeah, right now we have support for Rust, Go, TypeScript. But next, I was able to convince my boss we're going to do Ruby and Python. So I was a Ruby developer for the first 5 years of my career, and so Ruby has a really special place in my heart. I don't do as much Ruby these days, so I feel like kind of a black sheep at this conference, but I'm happy to be here. So, who's ever built Ruby from source? Anyone built it from source? Yeah, okay. The real OGs. It's nice. Yeah, so that can take a while. And if you build Ruby from source, you have to do some things like you have to have an operating system. Okay, so trying to do this to WebAssembly can be kind of challenging because, like I said, WebAssembly has no operating system, right? You need a file system in Ruby. That's a big one. Dynamic linking, some sort of way to do linking. Syscalls and libc, right? So like to open that file to connect to that network socket. Ruby kind of needs these things, right, to be able to do anything meaningful. So there were some pain points, There were some pain points with some of the early work that went on with Ruby on WebAssembly. Right now, Ruby 3.2, I believe, has a WASI WebAssembly deployment on the main branch. You can check it out on the GitHub. It's really cool. So you can run out of the box. It's the binaries too. You don't have to worry about the compilation. So one of the first problems, though, that we encountered with this was things like set jump, long jump, right? If anyone here has done C or low-level work, there's just one stack machine in WebAssembly. You can't really go to different parts that easily. So that was a huge problem, right? Because basically a lot of Ruby's error handling is implemented using these, right? Fibers. Wasm has no context switching, so it has no concept of this, right? So how do we deal with that? And the GC, you cannot inspect the types in WebAssembly from within the WebAssembly module. This is a huge problem too. So if anyone's ever built a garbage collector, God forbid, I know Tenderlove has, but I don't see him. So the problem with this is you have to be able to like see what kind of types you're working with, and WebAssembly makes that difficult on purpose, right? So there's a cool project here called Asyncify, which allows you to modify the stack and do things like rewind, copy stack frames, things like this. It's from the folks at Mozilla, and basically it accounts for many of these challenges that we faced. So I'm not going to go into too many of these because there's a much better talk by the guy who actually worked on it where he talks about these specifically. This is Yuta Saito's talk from Ruby Kaigi from last year or 2 years ago. He's done the majority of the work on this with the Ruby VM specifically, and that's an excellent talk. You should definitely check it out. So, cool. Okay, so now I'm going to talk about a project of mine that kind of abstracts away a lot of these details so that all of that technical stuff and all the problems that I just mentioned, like they'll just magically be gone with this project, okay? So this is a project called Boxer. If you've used Docker, you probably are familiar with a Docker file, okay? So this is a project that allows you to take a Docker file and then spit out a Wasm binary with it, with the actual runtime, okay? This is a link to it also. It's in a very experimental stage, but feel free to check it out, play around with it. Cool. So what's in a box? What's in a Wasm box? You've got the base layer, right? Kind of like if you are used to using Docker, Docker has image layers, right? Image layers are things like operating systems and dependencies and things like this. And really what those are sort of views into certain parts of the operating system and then permissions that are finely tuned, right? So the base layer here is just a set of interfaces. Then you also have a virtualized file system, virtualized system code. You have the compiled WebAssembly runtime, and then you have the user source code. And finally, also imports and exports. This is very important because like we talked about, WebAssembly it can only know what it is explicitly granted to know about, and nothing more, nothing less. Cool, right? So for example, you could take this Docker file from Ubuntu latest, you could make a directory app, you could copy your binary. This is a C example, but you could copy anything. Make this your working directory, and then run it. And that's that. This is a project of mine too. I'm going to get to the demo in a second, I promise. This is a project of mine too, which this depends on, which is a POSIX-compliant virtual file system, which then becomes its own Wasm module, which the source code can communicate with, and it has no idea that it's not on a Unix environment. It thinks it is, because it's just in WebAssembly, and it's all there for you, right? There are some differences. Things like sync, flush, lock are slightly adjusted, but between friends, it's basically the same thing. So. Okay, the actual demo now. Let's see. Oops. Too small. No, not that. You guys, can you see that a little bit? Okay. All right, so this is, I took this from the official Ruby image on Docker, right? This is Ruby 3.0 working directory. Just make this little working directory, copy my source code, and then run the actual Ruby app, okay? The actual application is just going to be this for now. I'll get to Rails, I promise. But this is just a simple Ruby app. This looks like valid Ruby, right? Looks okay? Okay, so the reason I want to point this out is that with this and this, everything else is going to be taken care of. And I can do something like this. So just like Docker, you can do like a Docker build. Please ignore my Rust errors. I haven't fixed them yet. So they're not errors, they're just warnings. This is written in Rust. Cool. Okay, Ruby build started. It found the base image, which is the whole Ruby VM, right? Like all of Ruby, the garbage collector, everything is compiled into this, right? Which actually is not bad. It turned out to be like 7 megabytes if you cut out the standard lib, which is pretty good. So it bundled the runtime, bundled the source code, bundled that virtual file system that I just talked about, okay? And then now it is ready to go, and it's just a .wasm binary, okay? So now, do one of these. Yay. Ruby on WebAssembly, everyone. Yeah, so, yeah. That is, yeah. Obviously not the most exciting demo ever, but I'm not done yet. So why don't we change this just to show you. Yeah. So we'll do this, try a different one. We're going to build it, and in the meantime, I'm going to show you I'm going to start these servers. Cool. Okay, so I changed the code. I just made it this like simple puts, hello Wasm, right? Blah, blah, blah. Cool. And it spits out, this is the actual code that it spits out. It just overwrote the last code, which is fun. And now I'm going to run that. Great, hello Wasm. Okay, so that is actual code that we just did, which is nice. It's fun. But like I said, the cool thing about WebAssembly is that it's actually universal, right? So we've got WebAssembly runtimes, like we have a server-side WebAssembly runtime that I'm using that's written in Rust. It's called Wasm time. Scale that we use is written in Go. It's called Was0. But they all implement the same 1.0 spec. You can think of it like JavaScript, where like all the browsers implement the same version of ECMAScript, right? Same thing in the browsers with Wasm. In fact, like we are all, so I'm a member of the W3C standards group that works on the new standards for Wasm, and all of the major browsers have people there who are also part of that group to help make sure that it's all going in the right direction, right? So same thing, WebAssembly 1.0 is implemented in every major browser, just like it is in these runtimes. So I can take that same code, right, with these interfaces, if I have them. Yeah, well, this is the actual binary. You can't read it, but you can read part of it, okay? Right? I can take that same code, and I can put it into the browser. Okay. This is the browser that just loaded it, okay? This has some JavaScript, which wraps the WebAssembly runtime that exists in the browser, and it loaded that code that we just compiled to Wasm. And now, what this did is I have a proxy server that's set up that took this GET request, proxied it into WebSockets, passed that to this page, executed the Wasm, passed that back to the WebSocket, and then in the response, here. So same thing, same exact thing. Same code. And the same code is fun because, especially that second one, I like to call that actually serverless, right? Because it's like not running on a server. Yeah, okay. So there are servers involved, but like because of the proxy, so I understand. Yeah. All right, good. Cool, yeah. So that's just an example. That's just a simple example that kind of shows like there is a way forward for running literally the same code in many places, regardless of, so for those of you that compiled Ruby from source, Ruby developers don't have to deal with this every day, which is nice. Actually, that's one of the beautiful things about Ruby. But like when you compile that from source, it has to be on the right machine. You have to compile it for the right machine. You have to find the right architecture, right? If you work with things like Rust or Go or C or C++, like you're worrying about that all the time. And then if you're working with embedded environments, things like phones are smaller or like controllers and lights, right? All these things have different architectures. So this is where WebAssembly could really shine and is actually starting to in the embedded device space. So people are using Wasm in embedded devices because if you've ever had to update the firmware on an embedded device to reflash your actual hardware, that's a huge pain. WebAssembly lets you keep the runtime there and use extremely fast, safe code on that same hardware. So that's a different talk, though, but I'd be happy to talk to you about it. Cool. Some big caveats, though. First one, threads. WebAssembly is single-threaded, but it's super fast, right? So you can use Asyncify for stack switching. And that makes it seem like it's fine. In the context of Ruby, it usually doesn't matter because like you are not going to do much unless you're doing some stuff using maybe like special, like doing stuff to get around the garbage collector. I don't know. I mean, threads are still a problem, but multi-threading is coming to the Wasm spec for sure. But it will be the last thing because if you think about it, using threads in a completely polyglot environment without a kernel is a very difficult thing to make. Right? It's a very difficult standard to devise. Native dependencies, the problem, right? So native dependencies in Ruby, like when you install Rails, I believe, still, I don't know if it still happens like this, there's this big C library you have to install, right? I think it's called Nokogiri, right? Yeah, I mean, I'm joking because I think Aaron worked on it. But anyway, that's written in C. It's got to compile down to your architecture, okay? That's a problem, but actually one of the cool things is what if you didn't have to bring in that specific binary for that specific architecture, and you could just use the same one on every architecture, and maybe even have that be safe and sandboxed and not able to do things like access your network and your file system without your permission. Because right now, if you compile a C binary, like it's there, it's doing its thing, right? With WebAssembly and WASI, you control that. By default, it will deny everything. So there's another project that I've got that's called Whacker, which does just this. And Whacker is all, has anyone been to Chicago? No? Yeah, cool. Okay, a couple people. This is kind of an homage to a street in downtown Chicago called Whacker Drive. But it's the WebAssembly package manager, okay? And what this does, this is very, very important for Python also, if people have done Python in this room, because Python, the joke, don't tell the Python people this, but like the joke about Python is that it's just a C wrapper. Have you heard this? Yeah. So Python uses like a lot of different native code, especially machine learning now, which is so popular. AI is so popular, right? This is a big hit with them because you can just compile it once and then run it anywhere. You can run it in the browser. If you've ever used Pyodide, which allows you to use Jupyter notebooks, like for data science, in the browser, that uses WebAssembly in this way. And this exact thing manages those types of dependencies. They use a different thing for dependencies, which I actually think is more cumbersome, and that's part of the reason why I made this. This is just a doc. It's not public yet. This is just like a document about it, but feel free to check it out. So anyway, I digress. Whacker also enables Rails. Okay, so like getting all the gems in, getting the right Ruby gems with the native extensions. The other thing about Python too, there's like, it's not just a C wrapper, it wraps things like Fortran, right? It wraps some like really crazy stuff that you have to deal with, which is like, if you've ever gotten in the guts of that, it's like a really, it's some serious make file fun, you know? So yeah, so when this becomes public, the demo that I just showed you will be the same sort of thing where we will have certain dependencies wrapped and then also taking care of how to adjust the types from like the C types to the Ruby types and then making sure that each module is separated in separate Wasm modules allows you to use Rails in Wasm. This is a little image that I had ChatGPT make for me. And it kind of exemplifies this, right? That's a container, a shipping container, and that's a box. It's like roughly the size difference. So Boxer, Docker, containers. Some key metrics. Containers. Ruby apps can be giant. At my last, so I was a Ruby developer for a while, then I was an infrastructure engineer, and then I was the director of infrastructure. And we had some Ruby apps that were like literally like I think like 1.8 gig, 2 gig, right? And like that was nothing compared to some of these other teams, you know? And so those are beefy containers, right? Like so much for microservices, right? And so so those, I mean, you could have like cold start times, like starting a container from 0, like 800 milliseconds at the best, the smallest, most stripped down, no standard lib, like. And then also, if you've used AWS Lambda, they do all these crazy tricks to try to preheat the runtime and to like keep the pods warm and stuff, and all of this voodoo. And that's costly. It costs you money. That's why AWS Lambda, even if you're not running it, costs you money, like a few cents that you'll never notice for the rest of your life, you know? And then containers also use a shared kernel, right? It might look like you're on your own operating system on a container, but you're not. It uses a sort of complex mesh of C groups, which were added to the kernel for this, basically, like by Google, I think in 2006 or 8. And then you need Unix. You need Unix processes, signals. Ooh, sorry. Everything that goes with that. Okay, I've got 1 minute. All right. Boxes, 7 to 14 megabytes, same size. So this demo, tiny, right? No standard lib, that made it easier. Startup speed, 100 microseconds. So like a tenth of a millisecond. And maybe up to a millisecond. Obviously, if you make it gigantic, it'll go up from there. But the startup speed is probably the most attractive thing about Wasm for server-side right now, which is why a lot of companies are using it for serverless functions. Serverless functions and WebAssembly are a much better fit than serverless functions and containers by a lot, right? So the thing I mentioned, scale.sh, you can use that as serverless functions, right? In fact, I've got a project that a personal one that I use them in that way. Security model, virtualized sandbox, machine code execution, right? Totally different paradigm. It's a paradigm shift. The future, full support for libc, syscall interfaces, imports, exports. This is what will be happening in the future with Wasm, and I'm actually involved in several of these endeavors. Modularizing the kernel, okay? So different pieces of the kernel, turning it into WebAssembly and being able to like plug and play. Has anyone heard of like unikernels? Unikernels? It's kind of like unikernels, but in a using Wasm, right? With better interfaces. Things like the context switching cost of going from user space to kernel space, it goes from milliseconds to nanoseconds. So it goes down by like 2 orders of magnitude, right? So it's very, very, very fast. So it can change a lot of these things. There's if anyone's interested in this, I'm working on 2 projects now that deal with this, and it's really cool, but super like nerdy, low level stuff. But I would love to talk to you about it. Yeah, so what does that allow for? A paradigm shift, kernel-free, composable, universal, Wasm-based operating system across the entire world. Browsers, servers. There are people who work in the WebAssembly space who think that, I was telling someone, where is he? People think in the WebAssembly space that in 5 or 10 years, it will be the minority to not be using WebAssembly, right, for almost everything. So kind of how we think of containers now, it's kind of an obvious fit. It's just very, very early. Yeah, and then you get true isomorphism. So the same code, literally everywhere, executed with the same guarantees. The only thing that might change is the underlying hardware, but it doesn't matter as long as it implements the correct runtime. Thanks. Appreciate it.
Thank you so much, Dan.